My name is Zach Thomas, and this is my charge tapes experiment. The purpose of this experiment was to determine the charges of the piece of tape as a point charge and as a line of charges. It was also to determine the gravitational and electric force on the tape and to create a glow script program to produce computational models of the two representations. Those two representations being as a point charge and as a line of charges. What I found was that the tapes both repelled each other and had a positive charge. The charge of the tape as a point charge was found to be 1.35 times 10 to the negative 8 coulombs, and the charge of the tape as a line of charges was found to be 1.23 times 10 to the negative 8 coulombs. I also found the magnitude of electric force to be 2.19 times 10 to the negative 3, and the magnitude of gravitational force to also be 2.19 times 10 to the negative 3. Some physics principles used included Newton's second law, which was used to calculate gravitational force, Coulomb's law, which was used to determine the tape charge, and the electric field formula. I also used the idea that objects with like charges repel and objects with opposite charges attract. The materials used for this experiment included one roll of clear tape, a flat surface, one ruler, and two thick objects, preferably books. The first step of this procedure was to create U-tape B by pulling the end of the tape off of the base tape quickly and placing it on the two books. The base tape is simply a neutral piece of tape that lies face down on a flat surface. I created U-tape A using the same procedure and placed it close to U-tape B and observed how U-tape B reacted. U-tape B reacted by repelling U-tape A, and as shown on the physics principles before, that means that these two objects have the same charge. I then measured the distance. So we know that these two objects have the same charge, but we have to measure what the charge of the U-tape actually is. And in order to do this, we have to observe how U-tape A reacts with a known negatively charged object. So the way I did this was I rubbed a plastic pen on my hair and then placed U-tape A close to it and see how they reacted. They reacted by being attracted to one another, and we know that that means that these two objects have different charges, and we know that the plastic pen had a negative charge, which means that U-tape A had a positive charge. The system for this experiment was U-tape A, U-tape B, and the two books, and the surroundings were everything else, and the initial conditions were the three pieces of tape and the two books. Some assumptions made included that both pieces of tape had the same initial net charge and were treated as point charges, and also that the tape charge was concentrated at the center of the tape, and also that there was negligible air resistance. Some possible errors included that there were unequal charges between the two tapes, and that touching the tape during the experiment could cause some of the positive charge to be lost during the experiment. Each piece of tape was modeled as a point charge in order to observe if they would attract or repel each other. So some other initial conditions included that the tape had a length of 0.223 meters, a width of 0.019 meters, and a mass of about 1 gram, and the distance between the tapes was 0.027 meters. Glow script was used to calculate the charge, electric force, and gravitational force. So here's my glow script representation as a point charge. As you can see, the output of the code was that the amount of charge was 1.35 times 10 to the negative 8 coulombs. So the gravitational force are shown in the yellow and green, and the electric force is shown in the orange. And on the right is my code. Now here's my glow script representation for a line of charges. As you can see, the green arrows show the electric field, the red shows tape B, and the blue shows tape A. And also the yellow arrow shows gravitational force, and the white arrow shows electric force. And also in the bottom left you can see the output for this code, which includes estimated tape charge, the magnitude of electric and gravitational force, and also the number of deficient electrons on the tape, and the ratio of number of atoms to number of electrons. So here's some more glow script calculations that were used in this line of charges code. So on the right is a calculation for the electric field using the electric field formula, and on the left is a calculation for the electric force. So some additional questions. My answer for the first question would be that the data would remain unchanged because the tapes would still have the same charge, so they would repel. My answer for the second question would be that the field of the point charge is different than the field of the line charge. The point charge model is less accurate because in real life the charge is distributed across the tape, not fixed at a certain point on the tape. So this distribution would be better displayed on the line charge model as opposed to the point charge model. And lastly, here are my two glow models. The top link shows the point charge model and the bottom shows the line charge model.